how do we know if something is metal? Like chemically, we know usually metals, what they do is that they have this thing that we call metallic character. And what's metallic character? It's the ability to lose electrons. That's what makes anything more of a metal, that it simply loses electron. Of course, there are physical properties like having high melting point or being shiny or being soft, but not all metals do that. But one thing that all metals do is that they lose electrons in any chemical reaction. Again, there are some exceptions in very few examples of that, but we won't go into that. Usually metals have this metallic character, which is about losing electrons. Okay, that's one. Second, we know that metals, when they react with nonmetals, usually that happens through an ionic bond. And what an ionic bond is, that metal would lose electron because it wants to get to zero in the last shell, and non-metal would gain electron because it wants to get to 8 in the last shell. And that's octet rule, and that's how they become stable. And so we would expect that metals and non-metals would make ionic compounds. And that is how ions will exist, which means that if you melt that thing or if you dissolve that thing, whatever is made by reacting metal and non-metal, it would conduct electricity because it has free ions, right? So if you melt it, it will conduct electricity. If you boil it, it will conduct electricity because it has freely moving ions in gaseous state. But if it is a solid, the ions are not free. They are held together by strong forces, and they have this lattice that's very hard to break out of, which simply means that they will not conduct electricity as solids, right? So that's what we know about metals and their chemical properties as far as reacting with non-metals is concerned. And the defining feature is that metals lose electrons and make ions. Today we are going to talk about a class of substances which are usually made by nonmetals. And the interesting part is that these things lose protons. Just like metals lose electrons, these things lose protons. And how they do that is that when they lose these protons, these non-metallic things, mind you, usually non-metallic things, they lose protons and they become ions. Just like metals, when they lose electrons, they become ions. These things lose protons and they become ions. And we have talked about ionization at length in electrolysis. So these things which lose proton, and obviously they need some help in doing that because they're nonmetals, water helps. In fact, water is a very interesting substance that if you have one water molecule and it comes close to another water molecule, then one of the water molecules is going to lose a proton. One water molecule here, let's suppose this one, it's going to lose its proton and give it to that one, which will make it H with 3 oxygen, 3 hydrogen now, and a positive charge because it has just gained a proton. And that other water molecule is just going to remain as OH minus. And what has happened here, by the way? Let's take a step back. Water was H and OH. What happened was that for some reason, this bond got broken and this water split into H positive and OH negative. And this thing, what is H positive? It's simply one proton with no electrons. So what is it? It's a proton. So H positive ion is nothing but a proton. So when anything loses a proton, when anything gives away a proton, we say that this is an acid. And that's what this water molecule is doing. And it's going to give that to this other water molecule, which is going to accept that proton. Okay, so to take the example of metals and non-metals, when one substance loses electron and the other gains electron, we say that one is metal, one is non-metal. One has lost electron, one has gained electron. So what do we call these things which are doing the same thing but with proton? So this one which has lost a proton, we call it acid. And this one which has gained a proton, we call it base. Okay, so acid and base. And because water is a substance which can act as both acid and base at the same time, we say that this is actually neutral. And that is why it's right in the middle of pH scale, right at 7. We say that this is where water lies. It is equal parts acid as well as base. All right. Now, water is interesting because it does something else as well. Now, this is kind of a circular definition. We have another important term, alkali, and alkali is a substance that gives OH negative ion in water. It has to be dissolved in water and must give OH negative ion. Look at this water molecule here. It has given the H positive, and what is left? OH negative. So water has actually done the act of both acid and alkali. And of course, saying that it is dissolved in water is kind of like, what else would it be dissolved in? It can't be dissolved in itself, but sure, it fulfills the requirement of the definition. So water is acid because it gives proton, the H positive thing, and water is alkali because it gives OH negative, and because it's doing it equal parts, it has 1 mole of H positive that it's going to give and 1 mole of OH negative that it's going to give, equal parts. That makes it a completely neutral thing. Okay, so let's just finalize the terms then. Acid, base, alkali. What's acid? A substance that gives H positive ion or proton, and base is a substance that accepts H positive ion. And if something does that in water, takes the OH negative ion, gives that, it is alkali. What that means is that all alkalis are going to be water soluble. And usually they have this hydroxide thing in them. Okay? And you can easily count which alkalis are there. So group 1 forms alkalis. There's a hint when we study group 1. What's the name of group 1 metals? What do we call them? Alkali metals. Yes, thank you, Alina. So they're called alkali metals because all of their hydroxides are alkalis. They dissolve in water and they give OH negative ion. Okay? Which is why they're called alkali metals. Now, group 2 does that to some extent. Not completely, but to some extent, which is why we call them alkaline earth metals. Okay, so the term alkali there, obviously that has to do with something being an alkali. So group 2, they do the same thing. They dissolve in water, their hydroxides are there, but to some extent, not completely. So they are alkaline earth metals. So calcium hydroxide, what's the name of calcium hydroxide? If it is dissolved in water, we call it lime water. And if calcium hydroxide is solid, we call it slake lime. Okay, so lime water is obviously a saturated solution of calcium hydroxide. Now that means calcium hydroxide is not completely soluble in water. Some of it is, some of it isn't. Just like that, magnesium hydroxide is partially soluble in water. Some of it is soluble, some of it isn't. So they are forming alkalis, but to a smaller extent. And all other hydroxides, mind you, they are not soluble. They don't dissolve in water. Okay, so they're going to be insoluble. Okay, so we have alkali, we have acid, we have base. The key term to identify whenever you have an acid-base reaction is, did that thing lose H positive or did it not? If it did, it is acid. If it took it, if it accepted it, it is base. And if it did that in water, or if it gave hydroxide ion in water, it's the alkali. So the water part is important there. Okay, so let's look at some acids. How do we name them? By the way, acids can be binary or they can be made of multiple atoms. So for example, if acid is just made of two atoms, like HCl or HF or HBr or HI, we'll just call it hydro for the hydrogen part, chlorine for the chlorine part, and IC to show that this is acid. So that IC at the end of the name tells me it's acid. This would be hydrofluoric. This would be hydrobromic. And this would be hydroiodic. Okay, so that's what these acids are. They have just two elements in them, and so we are going to count the hydrogen part. You will notice that all acids have hydrogen in them because obviously that's what makes them hydrogen. Okay, when you have more than two elements, so for example, if you have this thing, or if you have this thing, or this one, here what we do is that we do not name the hydrogen part, we do not name the oxide part. What we do instead is we put ate or ite in the name, okay, for the ion, that ion there. But when we are going to count the acid, when you're going to name the acid, we will just focus on this thing in the middle. Okay, so we will not say this is hydrophosphatic acid or something. We'll simply be like, okay, there's nitrogen in them. Hydrogen and oxygen is already going to be there. So we'll just say nitric. So the IC part tells me that this is acid, and nitrogen part tells me that there is hydrogen and oxygen there. Similarly, this one I'll call sulfuric. This one I'll call phosphoric. So that's what these acids are. They have IC at the end of the name. Now sometimes we, yes,
सर इनको मेरे ख्याल में फॉस्फेट नहीं होना चाहिए, सल्फेट या नाइट्रेट.
Very good. The ion must be sulfate. The ion must be phosphate. Lekin when they're part of acid, we don't call the ion, we call the whole thing. So uske naam mein IC tells me it's acid, and nitrogen is in the middle, so nitric, sulfur is in the middle, so sulfuric. वहां से
सर इनके अंदर हाइड्रोजन है इसलिए ये एसिड है.
जी बिल्कुल. That is why it's acid. Okay. Now sometimes we have acids which are organic. So how do we call anything that it's organic acid? We call OIC at the end of the name. We put that there. Organic acid. So O is for organic. So let's suppose I have CH3COOH. So here, this hydrogen is the one that's going to make it acid. So I'll call it ethanoic acid. Why ethanoic? Because it has two carbons. We'll get to that why are we counting carbons and why is it important? But because these are organic, carbon is the main thing there. So this is ethanoic. Similarly, if I had something like this, where I do have hydrogen making it acid, but this thing, it has three carbons, so I'll call it prop because there is three carbons, and OIC because this is organic acid. So that's how we name organic acids. Okay, we put OIC at the end of the name. Now some things are acidic, like they are not acids on their own, but if you dissolve them in water, they make water lose its hydrogen ion more than hydroxide ion. Okay, or in other words, they hold on to the hydroxide ion and they let hydrogen ion loose. How exactly they do that? That's not required for us in O levels or IGCSE. So those things we just call them, so those things we call them acidic in nature. So carbon dioxide is one of them. When carbon dioxide dissolves in water, you add it to water, and we are just doing an addition reaction. It's not addition reaction, but we're just adding it up. How many hydrogens? 2. How many oxygens? 3. So what kind of thing is this? Notice some similarity with these things. Carbonic, very good. So this has actually created an acid just by dissolving in water. For example, if I had sulfur dioxide and put it in water, now sulfur dioxide doesn't have any hydrogen to give away, but the moment I put it in water, what does it do? It just takes two hydrogen and makes this thing. And this is called sulfurous acid. That OUS part is there, but forget it. Like why exactly is there, we won't get into that. Similarly, if I have SO3 gas and I put it in water, it's going to form, I just add everything up, nothing fancy here. So this is sulfuric. So it's dissolving in water, it's doing that. I have nitrogen dioxide here. I put that in water. What do I get? H2NO3, nitric. So what's happening? These things don't have any hydrogen of their own. They don't have any protons to give away. But the moment they dissolve in water, they make water do the job. They make water lose that hydrogen ion. Okay? Pretty smart. And these things, if you let them loose in the atmosphere, atmosphere has lots of water vapor in it, and there are clouds that are filled with water. So if this gas goes up there and dissolves in that, that is going to come down as acid in the rain, which is called acid rain. Okay, and that will obviously eat up all the marble buildings that we have. It will damage the pH of the soil, so things won't grow as healthy as we would like them to be, and a bunch of other things. Okay, they will change the pH of seawater, which will damage the life quality for fish or other aquatic animals. So these gases, we don't want them to be in the atmosphere more than they can be. So carbon dioxide is natural. It just stays there. This acid is very weak, so it doesn't really matter. But these three things, they cause acid rain. If you put carbon dioxide in your question, that's going to be wrong. Okay, carbon dioxide will not cause acid rain because the acid is really weak. It doesn't damage the buildings as much. कोई इतना फर्क नहीं पड़ता है. Another reason it doesn't do that is because buildings are made from marble. Marble has carbonate in them, and this is also carbonate. So कोई फर्क तो पड़ता नहीं है इससे. But other gases, they are going to cause acid rain. So how do they do acid rain? They basically dissolve in water and make water lose the H positive. लेकिन हमने तो कहा था कि water is equal parts acid and equal parts base and equal parts alkali. The problem is if something does not let this OH go away, if it holds on to that OH and lets just the H positive go, so water is going to be pretty acidic. And that's what they do. They let the hydrogen part go, but not the hydroxide part. They just join or latch onto that. जिसकी वजह से acid rain होती है, basic rain नहीं होती है. Nobody has ever heard of that.
Sir.
Yes.
Sir, जो कार्बन है वो भी एसिड है ना?
Carbon acid नहीं है. Carbon dioxide acidic है.
हाँ जी वही सर.
Put it in water, it will make acid. Does that answer your question?
जी सर, ये कार्बन डाइऑक्साइड ज्यादा एसिडिक है कि ये कार्बोनिक?
Carbonic acid is acid. Carbon dioxide is acidic. It has an acidic nature. But carbonic acid is acid itself. तो carbon dioxide उसको बनाती है.
अच्छा ठीक.
Okay? हाँ. Okay. So this is how acids are and what different naming scheme that we have for them and all that. So that's one thing. Now, how do we identify bases? So let's go on to bases now. अच्छा, bases are easy to identify. Bases में हमारे पास हमें बस ये देखना है that what kind of a base will basically all bases except H positive. So हमें बस देखना है कि उसमें क्या है जो H positive accept करे. So H positive is a positive ion, obviously, and other positive ions can be replaced by it. That's one thing. Or it is also possible that any positive ion might want to replace H positive itself. I have HCl. There is another positive ion that is more reactive than H. It might come and replace it. In either case, reaction to ho gaya. So that's what bases do. They need to have a positive ion in them. तब जाके हाइड्रोजन के साथ उनका कोई तालमेल बनेगा. Okay? So that's the positive part. So I'll just say that that comes from metal. So there you go. All right. Now the next thing is, what is the metal attached to? Like what has the metal reacted with ताकि वो base की तरह act करे, ताकि वो hydrogen को accept करना चाहे या उसके साथ react करना चाहे. So there are multiple things. For example, metal can react with hydroxide, and as you know, hydroxide, which is OH negative ion, if you join it with H positive ion, it will make water, right? So ये hydroxide तो हाइड्रोजन आयन को ढूंढता है. So जितने मेटल हाइड्रोक्साइड होंगे सब बेसिस होंगे, उनको हाइड्रोजन आयन मिलने का मौका चाहिए और वो वाटर बना देंगे, वो रिएक्ट कर जाएंगे, न्यूट्रलाइजेशन कर जाएंगे. सो जितना भी पॉजिटिव आयन होगा अगर उसके साथ हाइड्रोक्साइड है तो उसने रिएक्ट करना है और उसने वाटर बनाना है. ऑब्वियसली इफ इट डिसॉल्व्स इन वाटर तो वो एल्कली है और आसान है काम, बट इफ इट डजंट इवन देन इट इज बेसिक. देन वी हैव metal oxide. Metal oxide can also make water to some extent, and no more than that, it can simply accept H positive. So metal oxide does that as well. The third one is metal carbonate. अब metal carbonate जो है ना, इसके लिए समझना जरूरी है कि carbonate होता क्या है. As you've seen here, what is carbonate? Carbonate is nothing but carbon dioxide attached to that O part in water. So अगर मैं इसको ऐसे ज्वाइन करवा दूं तो ये कार्बोनेट आयन बना देता है, या कार्बोनेट आयन ब्रेक डाउन होकर कार्बन डाइऑक्साइड और ऑक्साइड बना देता है. जस्ट लाइक नाइट्रेट ब्रेक डाउन होके NO2 और ऑक्सीजन के साथ ज्वाइन कर जाते हैं. सिमिलरली SO3 जो है वो SO3 जो है वो SO4 आयन बना देता है when it dissolves in water by joining with this. So ये सारे जो हमारे पास,
सर मुझे ये समझ नहीं आया ये वाला,
दोबारा बताता हूँ. I'll do it again. So carbonate क्या होता है? Carbonate is CO3 with -2, right? वो CO3 को आपने ऐसे सोचना है कि carbonate is nothing but carbon dioxide attached to an oxide. Similarly, sulfate is nothing but sulfur trioxide attached to an oxide. So they are all different forms of oxide. ऑक्साइड के साथ कार्बन डाइऑक्साइड रिएक्ट कर दोगे कार्बोनेट बन जाएगा, नाइट्रोजन डाइऑक्साइड रिएक्ट कर दोगे नाइट्रेट बन जाएगा, सल्फर डाइऑक्साइड रिएक्ट कर दोगे सल्फाइड बन जाएगा, सल्फर ट्राइऑक्साइड रिएक्ट कर दोगे सल्फेट बन जाएगा. So these ions are all formed when you join some gas with oxide. Obviously that's one way of forming them, but the important part over here is that these are what's going to cause metal to react as base. क्योंकि जहां ऑक्साइड होगा,
ये हाइड्रोक्साइड वाली इक्वेशन,
this one,
yes,
yeah, this is hydroxide. Sure, metals and hydroxides, they will accept H positive, but even if you have metal and oxide, that will also react and that will accept H positive to make water again. ठीक है, आप H positive लो, साथ में ऑक्साइड के साथ रिएक्शन कराओ, पानी बन जाएगा. ऐसे ही है ना, you take 2H positive and you just react to get water, right? So anything that accepts H positive is base, so metal oxides will readily do that, and metal carbonates will do that as well. Reason, carbonates have carbon dioxide and an oxide hidden inside them. So that's one thing. And there's another one which is ammonia, and I'll get to ammonia in a while. So ammonia also acts as a base. What is a base? Always refer to the definition. Anything that accepts proton, anything that accepts H positive. So let's see, ये हमारे पास different bases हो गई. So सोडियम है, उसको हाइड्रोक्साइड बना लो तो वो सोडियम हाइड्रोक्साइड बन गया, बेस होगा. उसको ऑक्साइड से रिएक्ट कर दो, सोडियम ऑक्साइड हो गया, बेस होगा. सोडियम कार्बोनेट होगा, बेस होगा. Because they all accept H positive. They can all react with H positive to accept it. Okay, so that's what bases are. अब ये हमें उनकी इंटरनल स्ट्रक्चर तो समझ आ गया, लेकिन हाउ डू वी टेस्ट? आपको एक रैंडम चीज मिली है, हाउ डू यू टेस्ट कि वो एसिडिक है या वो बेसिक है? सो फिजिकल टेस्ट होते हैं कुछ. फिजिकल टेस्ट क्या है? You just want to see whether it has ions or not. So physical tests can be that, does it conduct electricity? Like, can you do electrolysis with it? So yeah, if you have any alkali or acid, then electrolysis is possible. Kaise? You dissolve it in water with aqueous solution. You take acid, dissolve it in water. Water में dissolve करना जरूरी क्यों है? क्योंकि water उसको H positive lose करने में help out करता है. ठीक है? So you take HCl, put it in water. Water allows it to lose H positive. क्यों? Because you see, when we were studying electrolysis, we talked about ionization. So HCl, which is made of non-metals, you put it in water and it simply breaks down into H positive and chloride. And why is that possible? Because water helps it do that. वरना HCl पड़ा पड़ा तो solid होता है. लेकिन you dissolve it in water, it breaks down into hydrogen ion and chloride ion. This is ionization. We have seen this in electrolysis. So water has this weird ability to do that with things. To completely non-metal things. They can ionize. H2SO4, you take that, put it in water, it will convert it to H positive and sulfate ion because it's acidic. And that is why things that dissolve in water readily, that ionize, foreign से foreign, हम कहते हैं कि ये चीजें बहुत स्ट्रॉन्ग एसिड्स हैं या बहुत स्ट्रॉन्ग बेसिस हैं. सोडियम हाइड्रोक्साइड है, पुट इट इन वाटर, वैसे ही सॉलिड होगी. पुट इट इन वाटर, इट विल ब्रेक डाउन टू गिव अस सोडियम आयंस and hydroxide ions, which are both aqueous. But try to do that with ammonia and the things aren't that robust. Try to do that with ethanoic acid, for example. So that doesn't create H positive to a large extent, which is why when we're doing this, we usually show this with a straight arrow, an arrow like this, to show कि भाई वो ionize हो गया है. इस process को कहते हैं ionization. So if something does this fully ionized, that the moment it got a chance, it ionized. That is called fully ionization or ionizing fully. Yes.
सर आयनाइज का मतलब होता है कि जो वीक बॉन्ड्स होते हैं वो अपने आप ब्रेक हो जाते हैं.
नहीं, बॉन्ड्स के ऊपर आपने अभी बिल्कुल नहीं जाना. इसकी रीजन कि आयनाइज कर क्यों रहा है, वे बियॉन्ड ओ लेवल्स. वी वोंट स्टडी दैट इन ओ लेवल्स. ठीक है, हमने बस ये समझना है कि कुछ चीजें फौरन आयनाइज होती हैं और कुछ चीजें जल्दी आयनाइज नहीं होती. द थिंग्स दैट आयनाइज फुली और एट वंस, like HCl, like H2SO4, like sodium hydroxide, we say that they are strong at it. And things that don't do that, we say that they are partially ionized. We say that they are weak at it. Obviously, पूरी तरह ionized ही नहीं हो पाए. तो अगर वो acid है, तो वो strong acid है. अगर वो base है, तो वो strong base है. जो चीज फुली कर दे, पूरी तरह कमिट करके कर दे, वो स्ट्रॉन्ग है, वहां पे उसकी स्ट्रेंथ ज्यादा है, वो उस काम में अच्छी है. एसिड का काम है H पॉजिटिव देना, उसको मौका मिला, उसने सारे H पॉजिटिव दे दिए हैं, अच्छा काम किया उसने, वो अपने एसिड होने की एबिलिटी को पूरी तरह से यूटिलाइज कर रहा है. वी से दैट इट इज स्ट्रॉन्ग. एक एसिड है, उसे मौका भी मिला है, उसे पानी भी मिला है, पानी ने उसे हेल्प आउट भी किया है, वो फिर भी नहीं आयनाइज हो रहा, वो H पॉजिटिव दे ही नहीं रहा. अगर दे रहा है तो बहुत थोड़े से दे रहा है, तो विल से दैट इट इज पार्शियली आयनाइज्ड. इट्स वीक एसिड. वो एसिड का काम ही पूरी तरह से नहीं कर रहा है ना. एसिड का काम है H पॉजिटिव देना. CH3COOH के 1000 में से 4 मॉलिक्यूल वो कर रहे हैं, तो बाकी 996 जो है वो बस बैठे, दे आर वेटिंग फॉर समथिंग. तो दे आर नॉट गुड एसिड्स, दे आर वीक एसिड्स. बट HCl को मौका मिला है, हल्का सा पानी मिला है, उसने आयनाइज हुआ है, H पॉजिटिव सारे के सारे दे दिए. दैट इज स्ट्रॉन्ग एसिड. नाउ देयर इज ओनली वन way in our syllabus to figure out what's a strong acid and what's a weak acid, if we use what is called indicators. तो फिजिकल टेस्ट के लिए हम इलेक्ट्रोलिसिस करते हैं, लेकिन इंडिकेटर्स भी हमें फिजिकल टेस्ट के लिए आसान होते हैं. Indicators क्या हैं? These are chemicals that tell us, without having to do a lot of theory application or doing setting up a lot of things, you just use them to see whether something is acidic or basic. There's only one indicator in our syllabus that tells us whether it is a strong acid or a strong base or a weak acid or a weak base, and that is called pH. pH मीटर से हम चेक कर सकते हैं, या इंडिकेटर हमारे पास है यूनिवर्सल इंडिकेटर। पीएच क्या होता है? पीएच स्केल है 1 से लेके 7 और 7 से लेके 14। 7 इज राइट इन द मिडल, ये न्यूट्रल है। यहां जो चीज 7 पे है ना, इट इज इक्वल पार्ट्स एसिड इक्वल पार्ट्स बेस। उसमें उतना ही एसिड का पार्ट है जितना बेस का पार्ट है। उसका मतलब ये नहीं है कि ना वो एसिड है ना वो बेस है, उसमें इक्वल पार्ट है। जैसे वाटर, मैंने आपको एग्जांपल दिया, वाटर इज इक्वल पार्ट्स H पॉजिटिव इक्वल पार्ट्स OH नेगेटिव। वो एल्कली भी है, वो एसिड भी है, इक्वल है तो कैंसिल आउट कर जाता है, न्यूट्रल है। ठीक है, अच्छा। ऑन द लेफ्ट साइड these are acids, on the right side these are bases. ओके, अब इसमें एक और नंबर इंपॉर्टेंट है, 3 और 10। 1 से 3 तक जो होगा उसको आपने कहना है स्ट्रॉन्ग एसिड। 10 से 14 तक जो होगा वो स्ट्रॉन्ग बेस, और 3 से 10 के बीच में जो कुछ है वो वीक है, ऑब्वियसली 7 को छोड़ के। स्ट्रॉन्ग एसिड कौन सा होगा? आपको वो कहते हैं कि HCl है, बताएं इसकी पीएच क्या है। आप 1 लिख दो, 2 लिख दो, 3 लिख दो, लिख सो स्ट्रॉन्ग है। 4 पे नहीं जाना, अच्छा पॉइंट्स में भी नहीं जाना। इन O levels एंड IGCSE वी डोंट गो इनटू पॉइंट्स, सो 1.2 लिखने की जरूरत नहीं है, 1 लिखो। आपसे वो कहते हैं अमोनिया वीक बेस है, पीएच बताओ, आप 8 लिख दो, 9 लिख दो, चलो 10 लिख दो, 11-12 पे नहीं जाना। वो सोडियम हाइड्रोक्साइड आपको कहता है जी स्ट्रॉन्ग बेस है, आप 12 लिख दो, 14 लिख दो। आपने बताना है कि स्ट्रॉन्ग कौन सा है, वीक कौन सा है। और यही चीज हमें एक और चीज भी बताती है जिसको हम कहते हैं यूनिवर्सल इंडिकेटर। वो कैसे बताता है? सॉरी, व्हाट हैपेंड हियर, आई डोंट नो, सो आई जस्ट ओके, यू गेट इट। ठीक है, दूसरी चीज जो हमारे साथ ये करती है दैट इज यूनिवर्सल इंडिकेटर। यूनिवर्सल इंडिकेटर इज बेसिकली 2-3 तरह की चीज होती है। या तो आपको पेपर में मिलता है, एक पेपर है उस पर इंडिकेटर डिप किया हुआ है, कलर किया हुआ है, कोटिंग की हुई है, आप उसको यूज कर सकते हैं। उसको यूज करने का फायदा है कि आपने पानी में डिप किया, एसिड में डिप किया, बेस में डिप किया, वायर निकाल लिया, बेस को कुछ नहीं हुआ, बेस अब वैसी की वैसी है, आपने डिप करके निकाल लिया। On the other hand, you can get drops of it. You put that drop in that base, now that base will react with the universal indicator. Universal indicator is a mixture of multiple weak acids and bases. तो वो depending on what they are reacting with, वो different color देते हैं। तो उनके colors are just like rainbow colors. They start with a bright red on the very strong acid part, going to orange, going to yellow, until they're green at the neutral. अब वो exact neutral 7 पे नहीं होते green, वो 6.5 पे भी green होता है, वो 7.5 पे भी green होता है। Then they're blue and then they're violet or purple or whatever you want to call it. So इसका मतलब है, आपसे वो कहते हैं कि अमोनिया एक weak base है, तो कलर क्या होगा? ब्लू बोल दो। सोडियम हाइड्रोक्साइड स्ट्रॉन्ग बेस है, कलर क्या होगा? पर्पल बोल दो, वायलेट बोल दो। वाटर एंड न्यूट्रल है, क्या कलर होगा? ग्रीन। कार्बन मोनोऑक्साइड है, क्या कलर होगा? ग्रीन। वीक एसिड है एथेनोइक एसिड, क्या कलर होगा? येलो। स्ट्रॉन्ग एसिड है HCl, क्या कलर होगा? रेड। वो आपसे कहते हैं सल्फ्यूरिक एसिड भी है, HCl भी है, अब कलर बताओ, तो दोनों में रेड लिख दो। या अगर आपने चेंज करना आपको, तो एक में ऑरेंज है एक में रेड है, लेकिन दोनों स्ट्रॉन्ग एसिड है, रेड लिख दो, क्या फर्क पड़ता है? बट समटाइम्स एग्जाम में वो क्या करता है, देयर स्मार्ट। पेपर 2 में जो O levels का या पेपर 4 IGCSE का, उसमें वो ये करेगा, वो आपसे बोलेगा कि ये आपको खुद बता देगा। वो कहेगा जी HCl is a strong acid, it gives red color on the universal indicator. Give another way of knowing if it's a strong acid. अब आप वहां पे इंडिकेटर का काम नहीं कर सकते, नाउ यू नीड समथिंग एल्स। तो आप लिख दें कि जी इलेक्ट्रोलिसिस करेंगे तो बहुत ब्राइट बल्ब जलेगा और बहुत जल्दी रिएक्शन होगा, अब लिख दे उसका फिजिकल टेस्ट, पीएच की बात नहीं करनी. यूनिवर्सल एंड पीएच आर सिंपली द सेम थिंग, मेजरमेंट ऑफ द सेम थिंग. अच्छा, अब कुछ और इंडिकेटर्स भी होते हैं विच डोंट टेल अस द पीएच बट जस्ट टेल अस कि वो एसिड है या बेस है. वो इंडिकेटर्स कौन से हैं? वन ऑफ देम इज phenolphthalein. Phenolphthalein is basically an acid itself. Methyl orange is an acid itself, but they're weak. So they react with bases to give a different color and they react with acid to give a different color. तो हमें वहां से उसका पता चल जाता है. So phenolphthalein is colorless in acid and pink in base. Purple भी कह सकते हो आप, pink बोल दो. Methyl orange is yellow in acid and red in base. और बीच में एक पोर्शन होता है जहां पे वो ऑरेंज होता है, लेकिन दैट पोर्शन इज नॉट एग्जैक्टली 7. वो 7 के नीचे भी है, 7 के ऊपर भी है, तो इट कैन बी कंफ्यूजिंग. यू गेट अ वीक बेस, वो आपको आप बोलते हैं ऑरेंज, तो यू गेट अ वीक एसिड, उसमें भी वो ऑरेंज कर देगा, तो हमें पता नहीं चलेगा उससे कि वो एसिड है या बेस है. इसलिए हम इसको जब भी यूज करते हैं एग्जाम में, हम ऑरेंज की बात ही नहीं करते. We just say it's going to be yellow for acid, red for base. बात खत्म. हम कोई और तीसरा कलर देते नहीं है. And then there is the student favorite litmus. Litmus is red in acid, blue in base. Now these colors, अगर हमें यूनिवर्सल इतना अच्छा है तो हम इन चक्रों में पढ़ते क्यों? Why don't we just rely on universal? Thing is, these colors are sharp. आज लिटमस यूज कर रहे हो, द मोमेंट यू क्रॉस इनटू द बेस थिंग इट्स गोइंग टू गिव यू अ कलर. बट यूनिवर्सल इंडिकेटर इज नॉट शार्प, उसमें ग्रेजुअल चेंजेस आती हैं क्योंकि वो पीएच के साथ साथ चेंज करता है. इट्स गुड टू गेट पीएच, इट्स गुड टू डिटरमिन वेदर समथिंग इज वीक और स्ट्रॉन्ग, बट इफ यू जस्ट वांट टू चेक राइट अवे, द बेस्ट bet you have is litmus or methyl orange. And if you want to do titration, we use phenolphthalein for that because it's good for that. आसानी से कलर चेंज देख सकते हैं उसमें हम. So these indicators allow us to do very simple tests, look at, observe the color changes, and based on that we can determine whether something is acidic or basic, or even whether it's weak or strong in terms of acid or base. Okay, so that's what these things do. तो अगर आपने देखना है कि एक एसिड है, आपको कैसे पता चलेगा कि वो एसिड है? नंबर 1, जो सबसे बेकार तरीका है चेक करने का, एसिड खट्टा होता है. The sour taste, that's for acids. So anything that is sour is getting its taste from acids. So दूध खराब हो गया है, खट्टा हो जाता है. Reason, पुराना दही है, खट्टा हो जाता है. Reason, it has acid in it. Acid is giving its taste in that. ठीक है. Bitter taste comes from basic things. So soap is bitter. Don't ask me how I know that. But soap is basic because it has a bitter taste, and obviously because it's made from sodium hydroxide. Similarly, जो पुराने ड्राई फ्रूट्स होते हैं, कड़वे हो जाते हैं. Reason, they have a reaction in them that creates a base. तो वो कड़वे हो जाते हैं. They get a bitter taste there. Okay, so that taste comes from something having a base in it. But that's not a test we can use in the lab. Never. We are not going to be like, अच्छा बेटा HCl है कि पता नहीं क्या है, आप टेस्ट करके देख लो. No, we will never do that. ठीक है. So we need better tests. So एक टेस्ट है इलेक्ट्रोलिसिस, बिजली कंडक्ट करेगा, स्ट्रॉन्ग है तो ज्यादा बिजली कंडक्ट करेगा, you will get a brighter lamp, वो ज्यादा शाइन करेगा. But if you want to test through indicators, तो हमारे पास ये यूनिवर्सल इंडिकेटर है, वो हमें बता देगा कि स्ट्रॉन्ग है या वीक है. लेकिन हमें लिटमस नहीं यूज करना वहां पे, हमें मिथाइल ऑरेंज नहीं यूज करना, फिनोफ्थेलिन नहीं यूज करनी अगर हमें स्ट्रॉन्ग और वीक का पता करना है. हाँ, आपको नहीं पता एक चीज वीक, एक एसिड है या बेस है, उसके लिए आप इन तीनों को यूज कर सकते हैं. Okay, so knowing what to use and how to use, that's important for these things. So typical properties of acids हमने उन पे बात कर ली है. ठीक है. pH स्केल भी हमें पता लग गया है. 7 पे न्यूट्रल होता है, 7 से आगे पीछे वो एसिड होता है नीचे, और ऊपर होता है बेस. ठीक हो गया. अब एसिडिटी का हमारी जिंदगी में क्या रोल है? सबसे इंपॉर्टेंट जिसके ऊपर क्वेश्चन आते हैं वो है एसिडिटी इन सॉइल. सो सॉइल में जब H पॉजिटिव आयंस आएंगे तो वहां पर वो एसिडिक हो जाएगी, स्पेशली अमोनिया की वजह से. अमोनियम फर्टिलाइजर. सो आई वांटेड टू टॉक अबाउट अमोनियम. अमोनियम क्या करता है कि आपके पास ये अमोनियम है ना, लेट्स सपोज अमोनिया गैस आ गई है, अगर इसको H पॉजिटिव आयन मिलेगा it will create ammonium ion. Similarly, if you have ammonium ion and you try to break it down, it will break down to give H positive and ammonia. Now let's compare. How many hydrogen does it have on the left side? 3. How many does it have on the right side? 4. That means it has gained an H positive. So this is base or alkali because it accepts H positive. And this is acid because if you go left, ammonium changes to ammonia. It loses an hydrogen positive. Okay, 1 proton, it loses it. So हम कहेंगे कि all ammonium salts are acidic because they are all going to lose H positive. अब अमोनियम फर्टिलाइजर्स बहुत सारे होते हैं, ठीक है. अमोनियम नाइट्रेट इज यूज्ड. Primary reason we are using them is because they're also, all of them are also soluble. Water में dissolve होते हैं. Okay? So because they dissolve in water, they're like that. Okay? So they're soluble in water and they're acidic. So just remember that. All right? So that's how these are. So now we know ammonia, the nature of ammonia and ammonium. We know the nature of acids and bases, what makes anything acidic, what makes anything basic, what is acid rain, how it affects soil acidity and all that. In the next lesson, we are going to talk about their chemical reactions and how we can use acids and bases in industry. Okay? If you have any questions, feel free to ask.